Hello everyone, thank you for viewing this segment in Geotechnical Engineering on Sematic vibration effects on soil properties. So what are vibrations? You probably encounter them every day, such as your phone vibrating to earthquakes happening in your city. In science and engineering applications, vibrations are energy waves that travel through different kinds of mediums. This could be either in solid, liquid, or gas. These waves, similar to force vectors, have lateral, longitudinal, and vertical components. The most commonly known vibration events are earthquakes. Depending on the magnitude of the event, major destruction can happen. Earthquake release S waves and P waves, which move laterally and vertically. Propagation of these waves happen through the soil. Since the ground is not able to absorb all the energy then travels up into the building, and that is when we see movement. In engineering, the movement created can induce failure in the structure. Therefore, these events are taken into account during the design process. Another source of vibrations are from transportation. Homes located near subways, highways, and trains experience vibrations whenever vehicles are passing through. Due to the close proximity, there is not enough length for the waves to be absorbed, which causes waves to be easily felt by the surrounding structures. A study was performed to understand the different impact created by a bus and a truck traveling at 50 kilometers per hour. Based on fundamentals of physics, mass is proportional to force created. Therefore, it was observed that the magnitude of the bus was twice of the truck. Sources of vibrations also happen through construction. The development of new infrastructure requires a thorough inspection of the area. This is done to understand what would be the behavior of the land in response to the building process. Depending on the location, vibration readings are part of the permit process before starting construction. This is because the compaction of the soil sometimes requires force to be exerted. Other aspects of construction that also induce vibrations are hammering and dynamite. Homes close to airports are most commonly affected by vibrations since the energy waves released travel through the ambient air and are immediately felt by the surrounding structures. Complaints are filed by residents because they can feel these vibrations inside their homes, causing also windows to rattle. While on the topic of aircraft, there is also a very obvious release of energy during a space shuttle launch. If people stand too close to a rocket during the launch, the energy released into the air would be so great that the people would blow away as tree leaves. Therefore, designated areas for observation of the launch are pretty far away so people don't feel these magnitudes. The propagation of vibration waves that travel through soil depend heavily on soil composition and phase change. A study was performed by Dr. Long about the vibration induced on highways by vehicles in Atlanta and Tampa. It was then correlated to the different kind of soils found in each location. Georgia contained clay, and clay displayed no protection or absorption of these vibration waves. Soil properties are also defined through water content. In saturated soil, effective stress is driven by the combination of soil particles and water. When load is applied, both are equally important in distributing the load. During vibration events, the time between waves cause stress to increase in the soil. If the time variation is small, then the pressure builds up and is carried by the water and not by the soil, posing a problem to bearing strengths in the soil will no longer carry the pressure. Water content could alleviate stress or create failure. From the loss of thermodynamics, snow lowers the temperature in soil, which causes compaction in the layers. Therefore, during vibration events, the soil would be less flexible in allowing vibration waves to propagate and absorb the impact created by vehicles. In the spring, when the snow melts and the water table rises, the viscosity of the fluid does not provide the same support at the site, since there has been a physical phase change from snow to water. Water serves as a better medium than snow to allowing vibration waves to move freely. Similar to the fact that light can be reflected, there can be refraction with vibration waves. In this case, hydraulic properties in the soil are a high priority, since the height of the water table will not allow waves to travel with ease or prevent refraction. In engineering, these vibration events are captured through energy graphs to understand what the design should be able to absorb without causing failure. PSD graphs, also known as power spectral density graphs, are created to visualize vibration levels at different frequencies. In this graph, vibration levels have been isolated in the vertical, longitudinal, and lateral direction. HV, or horizontal to vertical graphs, show a ratio between vibrations felt horizontally and vertically. The PSD graph is showing maximum readings at 1.6 to 1.8 Hz. The area under the curve for the PSD graph represents the total amount of energy being inputted into the building. These levels and energy represented is what defines the engineering design criteria. Vibrations are present everywhere. In urban cities, the interaction between different structures cause vibrations to be felt with ease because there is not enough distance for the waves to dissipate. A study was performed to understand what would be the best alternative in preventing subwave vibrations from propagating. One of the solutions were open trenches located a few yards away from the subway. Data reflected that since there is a gap in the soil, vibrations get disrupted and there is a loss of energy when reaching the open trench. In cases where only soil is present, vibration waves could be 3 times higher. Phase changes, in this case from soil to ambient air, serve well in decreasing the energy waves. Next time you feel your phone vibrate or the earth shake, it is because there has been a release of energy. Thank you for watching, and this presentation has been brought to you from Geotechnical Engineering course at Florida Gulf Coast University.